Okay, I'm going to be going over the Unit 8 review with you. You will need a graphing calculator for this, so make sure you're prepared. So first of all, number 1, Part A, is asking us to make a line plot of this data. So a line plot, think of a number line, and we're going to have to put the values that are in this table onto this number line. I notice that 40 is my smallest value, and my largest is 49, so I have to fit that all. I'm going to go by ones. 41, 42, and I'm going to go all the way up until I hit 49. And then I'm going to put an X above each of these values according to what's in my table. So 48, I have one at 42, 40, 48 again, 46, 45, 48 again, 49, 47 twice, 44, 46, 49, 48 again, 46, and then 47. All right, so that is my line plot. Part B. Part B asks us to describe this data distribution. Well, it's either level, it's normal, or it's skewed, and it happens to be skewed here. The tail end is on the left side, so we want to say it's skewed left. Okay, Part C is asking us to identify the mean, median, standard deviation of the data. So in order to do that, what I'm going to do is I'm going to get to my graphing calculator, and you want to make sure that you put in all the values from the table by pressing Stat, hit Edit, and then put in all the values. And once all the values are in, go ahead and hit Stat again. Make sure you arrow to the right to get to Calculate, and you want number 1. Calculate, and this is going to list out all the values that we need. We need the mean, the median, and the standard deviation. So we'll start off with the mean. So the mean is with the X with the bar on top. So the mean here is 46.25. Our median is not on the screen. You actually have to arrow down until you see MED. And so MED is 47, so that's our median. Our standard deviation is your sigma, and sigma is 2.41. All right, let's go ahead and go to Part D. We're going to create a box plot and name the minimum, quartile 1, median, quartile 3, maximum, and your IQR. Okay, so let's go ahead and get these values here, and then once we get the values, it will be easy to create the box plot. So I'm going to first start off with knowing the minimum. We know the minimum, you have it on the graphing calculator here, is 40. You have your quartile 1, which is 45.5. You have your median, which is the 47. You have your quartile 3, which is 48. Oops. And then you have your maximum, which is 49. Okay, so let's go ahead and use that information to create this box plot. So basically a box plot is going to have a number line just like we had for the line plot. We're going to go ahead and label this. And now we're going to go ahead and put a line at 40. This is going to be our minimum. We're going to put a line at our 49. That's our maximum. Right in between these two numbers is our median, which is at 47. And then quartile 1 is 45.5. Quartile 3 is at 48. We're going to make a box out of this. And then we're going to go ahead and connect the ends. And that will be our box plot. All right, let's go ahead and go to number 2. Okay, so number 2 is saying that an owner of a bakery wants to know whether the customers like a new type of cake that is sold. Name the type of sampling method and if it is or isn't biased. So part A so that when a bakery isn't busy, we're going to give out samples and ask all the customers what they think of it. That is considered convenience. You're doing it at a convenient time for you to conduct this survey. So this convenience is considered unbiased. You're taking a look at all the customers that are in the store, whether they buy or not. And so we're just asking random people that are in the store at that time. Okay, part B. Part B asks the opinion of every 5th customer who buys the cake. If it's every 5th customer, that's a rule. And when you have a rule, that's systematic. And since it's systematic every 5th customer, it's also kind of randomly choosing every 5th. So this is considered unbiased. Part C, give customers who buy the cake a survey form to fill out and mail it in. All right, so if you're mailing it in, the person is going to volunteer to mail it in, so that's considered self-selected. Now, because we're letting the customers fill out the form and mail it in, this is actually going to be considered biased because it's not taking everybody in consideration. It's taking in consideration people who, you could look at it 2 ways. They bought this new cake, and so they possibly already like that type of flavoring, instead of taking everyone's opinion and advice. Or it could be that people really didn't like the cake, and so you're going to get a lot more people mailing it in saying, I did not like this cake and I didn't like having to spend this money on it. So this is considered bias. And D gives out samples to 2 to 3 employees at each nearby store or business. This is considered stratified because it's a little bit from every group. Since you're getting a little bit of every group, that's considered unbiased because you're getting a sampling of people from all different places. All right, let's take a look at number 3. So number 3, we have a histogram that shows the number of minutes that 25 people chosen at random had to wait in line at a grocery store one day. The standard deviation of the data is 2.0 and the mean is 5.5. So I'm going to go ahead and write that down for number 3 just for some information. Standard deviation is 2.0 and we have the mean. You could either think of this as 5.5. All right, so let's take a look at part A. Part A is asking you to find the interval of times that people had to wait within 1 standard deviation of the mean. So within 1 standard deviation means it could go either above or below this mean. So to get the lower number, we're going to basically take the mean and we're going to subtract 1 standard deviation. And then we're going to take the mean and we're going to add 1 standard deviation to find this interval. All right, the mean is 5.5 minus 2.0, and then 5.5 plus 2.0. So subtracting here, you get a total of 3.5, and adding this will get you 7.5, and this is the interval in which we are within 1 standard deviation away. Okay, part B. According to this graph, how many people had to wait within 1 standard deviation of the mean? So we have to find out how many people these are. Well, as we're looking at this, we want to make sure that it is in between 3.5 and 7.5. So I'm just going to go ahead and go through this table, and remember that this is a skewed table or a skewed distribution. So we're going to be just looking at the values between 3.5 and 7.5. So we're looking at all these people in between here. So there's 2 ways you could do this. You could take the total number of people, which we know that the total number of people up here is 25, and subtract out the ones that are not in there. So we basically have 1, 2, 3, 4 people that are not in there. So 25 minus the 4 is one way to do it. Another way is just to add every single one of these in between here. So this is 2 plus another 2 plus another 2 plus 3 plus 5 plus 4 plus 3. And that will also get you the same value. So either way that you want to look at it, for me, it's easier for me to say, let's subtract the ends from it. So there's a total of 25 people. I'm subtracting out the part that's not in the interval. So that's 1, 2, 3, 4 people. That gets you 21. Again, like I said, you could always add these in between. All right, let's take a look at part C. Describe this data distribution. All right, if I look at this data right here, it looks like it's skewed, and the tail end looks like it's on the left side. So I'm going to go ahead and say this is skewed left. And then part D. Part D says, suppose one person in the sample was chosen at random. According to this graph, what is the probability that the person had to wait in line more than one standard deviation above the mean number? So we're looking at the values that are more than, so it should be greater than, one standard deviation above the mean. So here's our mean, and then we're going to add one standard deviation. So our mean is 5.5 plus our standard deviation of 2.0. So we're looking at the values that are going to be greater than 7.5. So now we're going to go back into this graph and look for how many people were greater than 7.5. And if I look at my graph, I only have one person that's greater than 7.5. Okay, that's this 8th person. So 1 out of how many? 1 out of 25 people. And if you do 1 divided by the 25 people, you get a total of 0.04, I should say. So this is the probability. All right, let's go ahead and go on to number 4. So number 4 has test scores for a math test here. Let me move this up a little bit here. Okay, test scores for math tests are normally distributed. So this is normal, with a mean of 72 and a standard deviation of 9. So our mean is 72 and our standard deviation is 9. What percent of the scores are between 63 and 90, and what's the percent of scores that are below 63? So let's go ahead and enter the values on this normal curve. I'm going to go ahead and chop this up. I know this is, so we have here 4. So we should have 1, 2, 3, 4 here. 1, 2, 3, and 4 here. 1, 2, 3, 4. And if you remember your percentages, we have 0.15, we have 2.35, we have, hold on a second, let's see. We have 13.5, we have 34, 34, we have 13.5, we have 2.35, and 0.15. It's really small. Okay, so now we're going to go ahead and put in the values at the bottom of this curve. So keeping in mind that the very middle is your mean, which is the 72. And so what we're going to do is we're going to add 9 going up. So 9 plus 72, and then we're going to keep going up by 9. That's a 90. There's a 99. And then going down from there, we have 72 minus the 9, 63. And then we 54. And then 45. Okay, so for part A, it's asking us to find the percent of the scores that are between 63 and 90. So between 63 is right here, and 90, which is right here. That's what we're looking for part A. Okay, I'll just put it up here. This is part A. So we're going to have to add all these percentages. And the percentages that we have between here is 34, 34, and a 13.5. And so if you add that all the way across, we get a total of 82. Is that right? 68 and 82.5%. Or is it 81.5? Hold on. 34 plus 34 plus 13.5. 81.5, yeah. 81.5. So that's going to be the value between 63 and 90. For part B, it's asking us to find the values between, or no, so not between, below 63. So below 63 is talking about here all the way to the end. So this is part B, from here to here, this whole part. So for part B, the part that we're adding up is the 0.15, the 2.35, and the 13.5. So let's add that together. And we get a total of 16%. Okay. Let's go ahead and go to number 5. Actually, I'll break up the video here.